today our goal is to figure out how can we write equations and solve them to match different situations. So we have this view of this beautiful market here, and we have prices for different things. And they have given us unit prices, which means we have the price per, I think on all of these it's the price per pound, or on these pomegranates it's the price for each of them. So that's a unit price, the price per one of something. So let's start by looking at our warm-up today. We're going to solve these problems, but we're also going to talk about how we can write them as equations. So starting with number 1, this says how much would 3 pounds of dates cost? I'm going to be honest, I am not a huge fan of dates, but some people really, really like them. So according to our picture here, I found dates over here. How would you guys describe dates? They're kind of like, disgusting.
I've never tried this.
Izzy, how would you describe them?
Like a hollow grape.
Yeah, kind of like that. They're kind of a little bit chewy and squishy. Okay, some people love big noons, I think, are made out of dates. Anyway, let's get back on task.
It's horrible.
So we have 3 pounds of dates. So we need to write an equation. It says to define your variables and write an equation. So before doing that, though, let's talk about how could you find the price of 3 dates. Edie, what would you do?
Well, I think to buy 1 pound of dates it would be $4.95.
Yeah.
So I think it would be $4.95 times 3 because we want 3 pounds.
Oh my gosh, I love that. So let me write that as an equation. So you're doing $4.95 times 3, and that's going to give us our cost?
Yes.
Fantastic. All right. I like that you did a really nice job of explaining each part of your process. By the way, LB means pounds. I'm sure you knew that, but just to remind you. Okay, I saw a lot of you did long division for this. Can I show you guys something cool? So this is $4.95 is really close to $5. So I'm going to think of this as 3 times 5, which is 15, right? So I know that 3 groups of 5 is 15. But this right here is 5 cents less 3 times. So I'm going to take away 15 cents from here. So my total should be $14.85. Okay, so that's just another way to think about solving that problem. Okay, now the other part of your warm-up asks you to write an equation, and I'm going to give you a little bit of direct instruction about how to do that. So we have 2 unknowns, 2 things that we don't know. The first thing is the cost, and the second thing that we can manipulate or change is the number of dates. So I'm going to write that as C, which is the total cost. I see that a lot of you are writing this down with me because you know this is important. That's so smart. And I'm going to have D be the number of dates. So this is going to go back to what Edie said. When he was talking about, well, the price of 1 would be this, the price of 2 would be this. So I have that the cost is equal to $4.95 times the number of dates. And a couple of things to know about this is if I have $4.95 right next to this D, that means I'm going to multiply them. So in the problem we just did, if we're like, okay, well, how much do 3 dates cost? I'm going to say the cost would be $4.95 times 3, and those parentheses mean times. And we solved it above, and we know that it would equal $14.95. How are you guys doing? So far? Yeah. Oh, it should be. Good catch. Oh my gosh, I love it when you guys do that. Thanks for catching my mistake. $14.85. There we go. So we can also represent this as a table where we have the number of dates and the cost. So if we bought 0 dates, what would the cost be? Zilch. Should I write zilch?
Times columns, I think tomorrow.
If we bought 1 date, what would the cost be? You can just tell me.
$4.95.
Awesome. Oh, $4.85. 85. Remember I made that mistake earlier. And then we could also say if you bought 3 pounds. Yeah.
It's actually 95 cents because it's the answer that's 85.
Okay, you guys are right. We were doing just for one of them. Okay. There we go. So 1 date would be $4.95. All right, and then 3 dates would be $14.85. So we have represented this as an equation and also as a table. Okay, so we have it 2 ways. Okay. Just ready to do the next one? So our next problem says how much would 4.5 pounds of sweet blood oranges cost? So here's sweet blood oranges down here. And it says define your variables and write an equation to find the solution. Okay? So let's start by writing an equation. Matthew, what are our 2 variables?
$2.95 and 4.5 pounds.
So those are 2 things, like 2 pieces of information we have. I want to know about our variables.
Pounds and pounds. The cost.
Yeah. Maybe we'll do a P there. And total cost. Okay. And we know that they're $2.95 a piece. Does anybody know what our equation is going to be for this? Yeah.
It's gonna be $2.95 times $4.5.
We're going to get to that in just a minute. What's our equation that we could use for any number of pounds? Ryan, do you know?
4.5.
Our equation is going to be that our cost is equal to $2.95 per pound. Okay, and that's what we have down here. So if we had 0 pounds, we could put a 0 in for P. If we had 1 pound, we could put a 1 in for P. If we had 2 pounds, we could add a 2 for P. Okay, but our problem wants to know 4.5 pounds. So we're going to say our cost is equal to $2.95 for every pound, but we have 4.5 pounds that we want to find the price for. Okay, so let's go ahead and multiply this. This will be a good review of multiplying decimals as well. So 5 times 5 is 25. 5 times 9 is 45. Plus 2 is 47. 5 times 2 is 10. Plus 4 is 14. Okay, cross these out so don't get confused. Put in my 0. 4 times 5 is 20. 4 times 9 is 36. 37, 38. And 4 times 2 is 8. 9, 10, 11. Add these together. And I moved my decimal over 1, 2, 3. So I have 1, 2, 3. And since it's money at the grocery store, I don't know, it depends on if they round up or not. But they're probably gonna charge me $13 and 27 cents. So that's gonna be my cost. Okay, give me a fist to five about how you're feeling. This is, I'm totally lost. This is, I'm feeling pretty good about this so far. Cool, all right. Let's do our last one. Our last one's gonna work a little bit differently. So our last one says, if you paid $15 for ginger root, how many pounds did you buy? So ginger root is right here, and it's $2.50 per pound. Okay. All right. We have two variables. Lawson, do you know what our two variables are?
It would be money.
Okay. Can I say that it's like cost?
Yeah.
Okay.
And maybe shirts or
You're on the right track. I want to figure out like how much it would cost me. I would need my information about the cost per pound, and then what else would I need? Yeah, the number of pounds. Ryan, do you think you know our equation?
yeah.
What do you think it is?
I think it's $2.50 times
$2.50 times pounds. What does that equal to? It's going to be our cost, right?
Yeah.
Okay. And then keep going, because you're using this information, aren't you?
Yeah.
Okay. So what would we do next?
You would multiply it by 13.
So we have $2.50 per pound, but in this situation, we don't know the number of pounds, but we do know that we paid $15. Okay. So I want you to think for just a minute. How are we going to figure out how many pounds were purchased? All right, Maya, what did you do to figure out the number of pounds?
I divided $2.50 by 15.
It looks like on your work you have 15 divided by $2.50. Which we would write, if we wanted to do long division, it would look like this. Katie, how come that's going to work? I'll tell you it will work, but how come that's going to work?
You have to move the decimal.
So just as this is our division sentence.
It works because the question is asking how many pounds you bought, and since you spent the $2 and $2.50 is the pound, to find out how many pounds you bought is dividing the cost that you spent by pound.
Totally. All right, so she was right. We're going to move our decimal point over one place. So 25 does not go into 1. It does not go into 15, but it goes into 150. How many times? You listen, tell me.
6.
6, yep. 25, 50, 75, 100, 125, 150. And that's 150. And we have 0 left over. All right. So that last one was working backwards. All right, so we're going to look at a couple of examples here. But this time, instead, we're going to deal with just some numbers, and we have 2 going on here. So I'm going to walk you guys through this first one, and then I'm going to give you less and less help as we go along. So this problem says y, whatever y is equal to 100 minus 4x. Okay? The big thing that we have to remember, and you've been doing this in science, is that we have to balance our equations. So whatever's on one side has to be equal to whatever's on the other side, okay? So for our first one, this is really awesome, we're just going to use our order of operations. And so we can think of this kind of like a table with X and Y. And for our first problem, they said, okay, when X is 12, what is Y? And then when Y is 64, what is X? Okay. So I'm going to take this when X is 12, and I'm going to replace the X in my equation with 12. So I have Y is equal to 100 minus 4, but instead of writing X, I'm going to write 12. Okay, and remember those parentheses mean multiplication. So I'm going to follow my order of operations now. I have Y is equal to 100 minus 4 times 12 is 48. So Y is equal to, I love when you do that. I love that you were doing that. So Y is equal to 52. Okay, so that means when X is 12, Y is 52. Okay? And the cool thing about that is that this means that 52 is the same as, is equal to, is equivalent to 100 minus 4 times 12. Now this second one, there's a little bit more going on here. So instead of writing, so here's my equation, Y equals 100 minus 4X. But now I'm going to say that Y is 64. So I have 64 minus, is equal to 100 minus 4X. Okay? I would like for all of you to give a high five to someone you're seated next to. And I would like you to work with that person to figure out a way that you can solve for X. So Matthew, you would like to explain how you solve for X.
Yes. Okay, so what I did, so I started off with 100 minus 64, because if Y is equal to 100, then, and they say that Y is 64. Y is 64, so you do 100 minus 64, which then you would get 36.
Okay.
So then
So you knew this had to be 36, right?
yeah. So, which means that, what would X equal? So, 36, I did 36 divided by 4, which is equal to 9. So, X would equal 9.
Awesome. So you knew that this, in order to get to 64, we have to do 100 minus 36. But then we had to think about, okay, 4 times what is 36? Or use your fact families and say 36 divided by 4 is 9. Fantastic. Let's go to our next. Oh, let's fill out our table over here. So when X is 9, Y is 64. Let's go to our next one. So we have example number 2. Okay? I'm going to let you work with your partner on this one, and we'll come back together in about 5 minutes. All right. So I'm going to start by writing my equation here. Y equals 2. Instead of writing X, I'm going to do what's called substitute. I'm going to substitute in 10. All right, Ryan, help me out.
So you would have to multiply 2 times 10,
Okay.
because it's all the order operation. Which would be 20.
So Y equals.
Yeah, Y equals 20 plus 30.
All right.
And that would be
Y equals 50. So if we are setting up our table, when X is 10, Y is 50. Now we want to figure out when Y is 60, what is X? So let me set this up Instead of writing y, I'm going to write 60 equals 2x plus 30. Kaden, take us away.
So what you have to do is look at the problem, and if 60 equals 2x plus 30, that would mean 30 plus something equals 60.
Okay.
So it's kind of like a backwards problem. So 2 times x has to equal 30.
Okay, so this part right here has to equal 30.
Because 30 plus 30 equals 60.
Okay.
So 2 times 15. Oh, well, you could do 30 divided by 2, or just 2 times 15 equals 30.
Or you also said 2 times what equals
Yeah.
30, okay?
So that means x would have to equal 50.
Fantastic, and we'll add that to our table. Okay, here's our next example. This one's a little bit trickier. Right, tackle this one with your partner. Okay, so I have 2 problems here. One in which I know my x value and one that I know my y. So when x is 20, I want to know what y is. And when y is 35, I want to know what x is. So Clara, will you help me with A?
Yeah. So first you do 2.5 times x, and x equals 20.
Okay, let me write this out first. So I'm going to write y equals 2.5, but I heard you say x is 20 minus 25. All right, go for it.
So once you multiply, 25 and 20, you get 50.
Okay, so 2.5 and 20, right? Okay. So you're right, that's 50 minus 25.
And then when you subtract that, you get 25.
Fantastic. And y is 25. So for our second one, we have y, which we've said is 35, is equal to 2.5x minus 25. So what our problem here is that 35 is equal to some number that we don't know yet minus 25. So I'm going to take this value here. And what we know is that we have some number here minus 25 has to equal 35. Okay, so we have to figure out what this number is going to be. What this has to be that after 25 is subtracted is going to be 35. So I'm going to show you a little strategy you're going to learn more about in 7th grade. But I'm going to add this 25 to this other side. So I know that 60 is equal to 2.5 x. Okay. So now I have to figure out 2.5 times x times what is going to be 60. So I can take this and do 60 divided by 2.5. Move each of these over. 25 does not go into 6, but it does go into 60 2 times. Awesome! Subtract, I have 10 left over. And how many times does 25 go into 100? 4, and that's 100. And we'll subtract. So what we know is that 24 is equal to x. On the next page here, we have some sample problems that I would like you to tackle with your partner. This is the end of the video.